Hi everyone, this lesson is a continuation of the lessons that I already developed in Algebra 2. This is entitled Lesson 1.2.1 Properties of Exponents Part 1. As always, when students are entering the classroom, show this slide on screen. The teacher is advised to meet the students at the door and hand in to each student a copy of the bell ringer. When the bell rings, click this slide which reminds students that they have 5 minutes to complete the bell ringer. While students are doing the bell ringer, the teacher will check their attendance, then distribute the classwork sheets. At the end of the 5-minute period, discuss with students' participation the bell ringer. Then present this lesson. Lesson 1.2.1 Properties of Integer Exponents Part 1. By the end of the period, with at least 80% mastery, students will be able to define integer exponents and powers, and apply the rules or properties of exponents. Definition of integer exponents. Let A be a real number. If n is a natural number, then a to the n means a times a times a times a and so on times a n times, where a to the n is the nth power or exponential expression, a is the base, and n is the exponent. For examples, 1, 3 to the 4 means 3 times 3 times 3 times 3, which is equal to 81. Here, the base is 3 and the exponent is 4. Number 2, negative 2 to the 5 means negative 2 times negative 2 times negative 2 times negative 2 times negative 2, which is equal to negative 32. Number where the base here is negative 2 and the exponent is 5. Number 3, x to the 6 means x times x times x times x times x times x. Here the base is x and the exponent is 6. Rules or properties of exponents. Let a and b be real numbers and let m and n be integers. Letter A. Multiplication properties of exponents. Number 1. The product of powers property, which is written in the form a to the m times a to the n equals a to the m plus n. In other words, therefore, we will just add the exponents and keep the base. So, to multiply powers having the same base, keep the base and add the exponents. Example number 4. Simplify the following. Letter A, 5 to the 2 times 5 to the 3 is equal to 5 to the 2 plus 3, which is equal to 5 to the 5, or this is 5 times 5 times 5 times 5 times 5, which is 3,125. Letter B, negative 3 times negative 3 to the 5 is equal to negative 3 to the 1 times negative 3 to the 5, which is then equal to, using the formula, negative 3 raised to 1 plus 5 equals negative 3 to the 6, or 729. Letter C, 6 to the negative 8 times 6 to the 12 is equal to 6 to the negative 8 plus 12, or 6 to the 4, which is 1,296. X to the 6 times x to the 10 equals x to the 6 plus 10, or x to the 16. Letter E, x to the minus 5 times x to the 8 equals x to the minus 5 plus 8, which is x to the 3. The second formula is called the power of a power property, which is written in the form quantity a to the m raised to n equals a to the m times n. Means to find the power of a power, multiply the exponents. Example number 5. Simplify the following. Letter A. Quantity 5 to the 2 raised to 3 equals 5 to the 2 times 3, which is equal to 5 to the 6, and multiplying or expanding 5 to the 6 is 15,625. Letter B. Quantity negative 3 to the 2, all quantity raised to 5 equals negative 3 raised to 2 times 5, which is negative 3 to the 10, or is 59,049. Letter C. Quantity 6 to the negative 2 raised to 4 equals 6 to the negative 2 times 4, or this is 6 to the negative 8. Letter D. X to the 6 quantity raised to the 10 equals x to the 6 times 10 is x to the 60. Letter E. X to the negative 5 raised to the quantity raised to 8 equals x to the negative 5 times 8 equals x to the negative 40. The third formula is power of a product property. This is expressed in the form quantity a times b raised to n equals a to the n times b to the n. To find the power of a product, find the power of its factor and multiply. Example number 6. Simplify the following. Letter A. Quantity 5 times 4 raised to 3 equals 5 to the 3 times 5 to the 4, 4 to the 3 equals 125 times 64, which is 8,000. Letter B. Quantity x times y raised to 10 equals x to the 10 times y to the 10. Letter C. Quantity negative 2 n to the 4 n to the 6 raised to 2 equals negative 2 raised to 2 times m to the 4 raised to 2 times n to the 6 raised to 2. Simplifying, we have negative 2 to the 2 times m to the 8 times n to the 12, or this is equal to 4m to the 8 n to the 12. Letter D. Quantity negative 16x squared y to the 4th times quantity negative 5x y cubed. This is equal to negative 16 times negative 5, x squared times x times y to the fourth times y cubed. Simplifying further, we have 80 x cubed y to the 7. Letter E. Quantity 4x cubed y times 0 times quantity negative 12x fourth y squared. Of course, we expect that the answer to this one is 0 because any number multiplied by 0 is 0. Example number 7. Simplify, then find the value of each for x equals negative 3 and y equals negative 2. Letter A. Negative x cubed times negative 4x is equal to positive 4x to the fourth. Substituting the value of x, which is negative 3, to this expression becomes 4 times negative 3 to the 4 equals 4 times 81 equals 324. Letter B. Negative 3y cubed times y equals negative 3y to the fourth. And since y is negative 2, then substituting we get negative 3 times negative 2 to the fourth equals negative 3 times 16, which is equal to negative 48. Letter C. Negative 2x to the fourth times x equals negative 2x to the fourth times x, or negative 2x to the 5. And substituting the value of x, which is equal to negative 3, this becomes negative 2 times negative 3 to the 5 equals 406. Letter D. Negative y squared times y times negative y equals y to the fourth. Or, since y is negative 2, negative 2 to the fourth equals 16. Letter E. Negative 4x times negative 2x cubed times negative x equals 3 negatives is negative 8x to the 5, which is negative 8 times negative 3 to the 5, since x is negative 3, and multiplying we get 1,944. Letter F. Negative 2x cubed times negative y to the fourth. So, this is 2x cubed y to the fourth, which is after substituting x equals negative 3 and y equals negative 2, we get 2 times negative 3 to the 3 times 2 to the fourth equals 2 times negative 27 times 16. Finally, our answer is negative 864. If there are no more questions, then let the students complete the classwork until the end of the period.